We have an incredible moderator, Somak Chattopadhyay. He is here from Armory Square Ventures. He's been in the game for probably 25 years in New York, doing early stage venture investing. He does B2B investing and is an incredible thought leader, investor, and advisor in the space. And is just a fantastic human. Very excited to have him here today. And a fun fact that we share in common is when he was going to college, he tried to figure out should he go to conservatory and become a musician or instead do what the rest of us did. He decided to go to MIT, and it looks like that's worked out for him. But he is still a not so secretly aspiring musician. So if you want to hear some of his jams, you can come talk to him after. But with that, Somak, over to you.
Okay, thank you so much. And I also learned that you are also a conductor of the San Francisco Symphony. We have I was at the MIT board meeting 2 days ago, and they were talking about how so many people from MIT are these creative polymaths, and you clearly are that. So thank you for the very generous introduction. So we have a very fun, exciting panel today. The topic is actually, challenges and opportunities in infrastructure AI. And I have a really distinguished group of people here. I'll let the actual speakers introduce themselves, but we have a variety of perspectives from startups to larger enterprises like Amazon and NVIDIA. It's a very, very exciting topic. And so we'll keep this brief, and I'm going to make sure I actually leave time to take some of the interactive Q&A. And actually, I might ask one of you all to help me make sure I'm getting these questions, because it looks like the poll's good. Okay, maybe there's no questions yet. Is that what it is? Okay. Got it. So just to frame the discussion, I wanted to just talk about just how excited I am also that this is taking place in New York. So when I graduated from MIT in the 90s, New York was not really considered, something that was like a leading edge technology center. It was considered a backwater of tech. And then what was interesting was when the internet bubble burst in the early 2000s, there was a lot of emphasis not focusing on just innovation for innovation's sake, but what did the enterprise want? How do people look at build versus buy? And one of the themes I want to touch upon is when I look at what some of the other speakers talked about, when they talk about issues related to talent or selling into the enterprise, making sure this is a must-have, ROI. These were all things that were real challenges during the internet era, during the Web 1.0 days. And there were also real constraints related to compute. Really, there was no cloud computing. There were physical servers. Today, we have similar constraints on the chip side. But there's also a real skills gap that we'll talk about today. So what I wanted, when you look at the actual productivity from AI, I'm on a board with Governor Hochul and Arvind, the CEO of IBM, the CEO of JetBlue and Pfizer, and we're looking at the productivity gains from AI. We're talking about potential $1 trillion in productivity gains, in globally, but a lot of that's here in the US. 100 billion of that is going to be in New York. And that's because a lot of the Fortune technology buyers, a lot of Fortune 50 technology buyers are all here in the New York tri-state area. And there's really sometimes a disconnect between what they need and what ultimately startups and vendors are pitching. So I'll turn it over now to the speakers to introduce themselves. We'll start with Jonathan.
Hi, I'm Jonathan Cohen. I'm a Vice President of Applied Research at NVIDIA. I've been there a long time. I lead a bunch of projects, but I guess most notably the NeMo project, which is our platform for large language models.
Hi. Hello, can you hear me? Okay, there we go. Hi, my name is Dawani. I'm the co-founder and CEO of Lemurian Labs. We're fundamentally pioneering accelerated software so model developers can build their applications and their models while staying in high-level frameworks, and they can accelerate it on any kind of hardware, regardless of whether it's at the edge or in the data center, on premises or cloud. And we can support just about anything from chips for training or inference or whatever you can imagine. Fundamentally allowing developers to be as creative as possible and imagine anything, but they get this one stack that gives them these massive productivity gains, so that instead of doing the whole 6 months to a year of just the development cycle, you can get to production in weeks.
Thank you.
Hi, my name is Sherry Marcus. I lead Bedrock Science for AWS. Bedrock is AWS's premier generative AI service, and my role is building out all of the tools and analytics for Bedrock.
Daniela Braga, founder and CEO of Defined.ai. We are the largest marketplace of training data for Gen AI ethically sourced. We make sure that we're focusing the pre-training data mostly for the builders of Gen AI. We also we are also in the post-training data, so in the fine-tuning with specific data collections. We make sure that our customers don't get showed up in the front page of the New York Times for copyright infringements.
Thank you. Thank you. So let's start, because this is a panel on infrastructure AI. Sorry, I keep dropping this. Why don't we start first with the compute part of infrastructure in AI? And so I'll start with you, Sherry. You obviously lead the generative AI efforts at Amazon, and you have an inside look at what ultimately is required in terms of the infrastructure needs. Now, Amazon was obviously an early pioneer besides doing stuff in commerce and cloud computing. Can you talk about how the computing needs have evolved just over the last 2 years, especially with the rise of generative AI?
Yes, 100%. So with the advent of large language models, compute and particularly inference is extremely expensive. So being able to utilize large language models in Gen AI applications where the models can be in the near trillions now of parameters is very, very costly, requiring lots of compute, whether it's from providers such as NVIDIA or others. In the last 2 years as well, what I've seen is just lots more focus on optimizations of these large language models where you're doing model customization, which means, different types of fine tuning or distillation on these large language models, which has been helping customers quite a bit, building out applications in terms of lowering costs and increasing accuracy.
Thank you so much, Sherry. And Jonathan, NVIDIA is obviously, one of the most important companies in the whole area of generative AI. And when you look at AI, there's obviously both the software and the hardware component, and on the chip side, it's really the picks and shovels of generative AI, right? So there's been a lot of news about NVIDIA in the press, obviously about how you guys are trying to keep up with the incredible demand on the hardware and software side. And when you look at hardware innovation cycles, it used to be, you'd be releasing new hardware products every few years, and now that's being condensed to months. So how do you at NVIDIA keep pace with, how quickly things are moving in the area of AI?
I think it's not quite months. I hope it's not months. We're on an annual cadence now, which is quite a bit faster than it used to be. I guess the way NVIDIA always approaches this is not so much chip or system or software, but the term we would use is accelerated computing platform. So you have some workload that you care about, inferencing over large language models. And what you care about is doing as much of that, as in your data center at as high throughput with as low cost as possible. And I think NVIDIA's strength has always been, and other companies do this too, but NVIDIA's strength has always been thinking about the entire stack. So we have chips, and we're revving the cycle of our chips, let's say annually, and we have layers of software that run on those chips. But that software we release monthly, and so we might have a chip an architecture that we shipped 3 years ago, and you're still getting software updates. We're still able to innovate at the algorithmic level, even on top of the software. A better architecture, a better mathematical trick implemented in the software layer, taking advantage of some hardware feature. And maybe on a newer chip, there's some new hardware feature that you can leverage to get some extra acceleration that wasn't available on the older chip. But the idea is, we know when you have a 1-year hardware product cycle, most companies are upgrading on more of a 3 or 4 year cycle, right? And you can't just abandon everybody who was on the generation, 12 months ago just because you have a new thing coming out. So, we make a big commitment with our platform to have this kind of notion of like forward and backward compatibility. People have heard of CUDA from NVIDIA, but what made CUDA so strategic, I think a lot of people don't even really know like what is CUDA, right? But what makes CUDA so strategic is CUDA is this API layer on top of the chip that NVIDIA made a very strong commitment to in 2007 when we first launched CUDA, that it would always be compatible. And so we can rev the chip underneath, and we can innovate the architecture and do really radical changes, but it still runs the same CUDA code. And so the work that you do today to optimize, on a chip today, it actually works on older chip and it'll work on future chips as well. And so I think there's a lot of engineering and a lot of kind of strategic technological planning that went into building this stack that allows us to, not force enterprises to throw everything out every 12 months and when they want to adopt a new thing just to get the benefits of the work we're doing.
I'm going to move to other panels shortly, to give perspectives on data and trading. But I just want to just build on this issue of the annual cycles that you're talking about releasing hardware. The CHIPS Act was really, designed to bring more of those manufacturing jobs here in the U.S. And I'm sure those of you know about the I corridor here in New York State. Micron's making massive investments, obviously here in New York State, but you've got TSMC, Samsung. There was people trying to bring this to the U.S. I'm just curious, with some of those trends, do you think that could help accelerate development cycles on the hardware side? What's your general thoughts about that? Because I know you said this, you're basically releasing annually, but TSMC was used in the prior, periods to do it every 2 years, 3 years.
So first of all, I just want to say I don't work on the hardware or manufacturing side of NVIDIA. So my perspective is very software perspective. But the manufacturing capabilities are like a constraint you live with. This manufacturer is able to produce, these kinds of transistors which have these properties. But there's a lot of other innovation on top of that, right? At the level of actually designing the circuitry, designing the algorithms that you're going to embed in the hardware. And for example, you can support lower precision arithmetic. That's not really related to how small a transistor you can fabricate. That's an innovation that you might bake into the hardware, but it's kind of independent. And so we can produce a new chip maybe in the same manufacturing process, but it might have much higher performance on some workload because we've improved at the algorithmic level that we're implementing in hardware. We're making other improvements. So again, when you think about this kind of whole stack of technology you're building, by thinking about it holistically, you can deliver acceleration and innovations at every level, and they're multiplicative. I make the process 10% more efficient, that multiplies by everything else. An algorithm that's twice as efficient multiplies by everything else. And when Jensen Huang, our CEO, talks about that we get these million X every 10 years, these sort of crazy numbers that people have started calling Huang's law, which probably amuses him. That's what he's talking about. It's not like a manufacturing fact or something. It's that you can innovate across the whole stack and all these things multiply. And when you multiply a bunch of numbers together, the speed ups can be quite large.
Well, actually, just, when you're mentioning that a lot of it is actually on the software side and optimizing the actual hardware, that's an area that maybe, Jay, you can talk about some of the things you're doing at Lemurian. Can you talk a bit about how you're addressing specifically the ability to kind of optimize things more efficiently?
Yeah, absolutely. So as I mentioned, what we're really doing is accelerated software. So you write your code once and it'll run anywhere and at any scale on any hardware. Now, obviously, NVIDIA is an amazing platform, and I've been using it for almost a decade now for almost all the work that I've done. But a lot of companies that we've encountered, they're trying out inference chips or they're trying out really new chips. Amazon's got Trainium and Inferentias. Google's got the TPUs. Meta's got their MTIA. Microsoft's got the Maya chip. There's AMD, there's Intel, and there's a lot of startups out there. And most of them, for most people using those chips, getting performance out of it is really hard, right? There's no existing robust platform like CUDA for them. So what we were really thinking about is, how do you give them performance and portability and productivity as developers so that they can scale and do all of their workloads, right? And part of that started when we were actually looking at designing chips ourselves, right? And we'd seen the struggles of what does it look like to get new software out there in the world. And it's a really hard problem, but you need to make that easier for people to actually leverage the hardware, right? Because the hardware can only do so much for you at this point. We're starting to move into more heterogeneous systems, right? And we're very used to programming homogeneous processors, but it's very non-intuitive now, right? So you have CPUs, GPUs, NPUs, TPUs, and all other kinds of XPUs, and each of them wants to be programmed just a little bit differently, right? The way your code will map out to that hardware is different. You have different number systems, for example, right? And each number system has its own variant. So think about FP16. I think about FP32, there's TF formats, there's log number systems, there's integers, and each of them has different characteristics. right? And a lot of people, to get performance, will think about multi-precision workloads, right? So that's the kind of work that we do. So that you don't have to think about it. Our stack takes care of that for you, and it'll lay out the work to get the most out of that hardware. So like our joke internally, or at least what we say what we're doing is our aspiration is push PyTorch to the limit of physics.
Got it. Well, I want to actually take some audience questions. Now, there's a bunch of questions here related to data, and this is a great, I think, segue to what Daniela does, right? So, Daniel, maybe you could talk a little bit more about what your focus is at Defined.ai, and specifically, when you look at what's so important in AI is ultimately having, the right type of data and make sure you're using data in an ethical manner. And data is ultimately the real oil of the AI industry. So can you talk a bit about some of the things that you're doing at Defined.ai to make sure you're using data properly and ethically?
It's a lot to unpack there. Let's see how we start here. First of all, customers have to make a decision whether they're going to build or buy a model or Gen AI application. If they're going to build, and if they're going to buy, the considerations are similar, but if they're going to build, all AI starts from data. It's the blood life of AI, right? So, and at that point, you have to make a decision on where am I going to source my data? Data is expensive. I mean, besides compute, that's the most expensive other asset in this tripod of which I usually say it's talent, it's data, and it's compute. And as Jonathan was saying in the panel before, talent is also very expensive these days, of course. So in the data part, people have to decide whether they're going to use data for training or for display. And for display, meaning it's mostly those applications that turn out to be a text-to-speech voice, that turn out to be a replica of the likeness of someone, of the image of someone. So that part, so there's, in every of these cases, this is how we help navigate, how I help our customers navigate. Anything that is public data is never really free of copyrights. That's a misconception that the world has gone through in the last few years. And now we see 25 active lawsuits against very respected and very well-funded companies out there, on which a lot of other even more respected companies are building brands, building applications on top of. And this is a liability, of course. So it's starting with how do we source data that is copyright free? How do we trace all the documentation back to consents of the participants? How do we have the most thorough ethical questionnaire, which is really a legal questionnaire on our partner data. Our marketplace works as a marketplace. We bring small, medium companies, content creators, authors, every single, it's Gen AI based. So musicians, producers, all types of people all over the world. We vet them in our marketplace and we license their data towards companies that are building. And this is the safest way to do this type of content. And then there's another level, which is, okay, there's always gaps in the world of data out there. We have to collect data, and for collection, we have our own platform. For that, and that again has a long list of consents, and everybody gets paid. In the end of the day, this is the most important part.
Got it. Well, you mentioned an important point about talent, and actually, this is something we heard in some of the prior panels as well, right? So I think some of the things that people talk about talent, we hear as VCs is, oh my God, it's so difficult to get people who truly understand how generative AI works. Maybe they were trained in machine learning and older types of software tools, but the world is changing quickly. So those type of salaries that people are commanding now are like, it's just crazy. It's like, being an NFL star, right? It's really real war for talent there. But there's also, as you mentioned, there's issues of talent in the enterprise. So you have to understand, if you're selling into a customer, the people who you're selling to have to understand how these tools work, how to modify those tools. And as Aditi mentioned actually this morning, I thought it was a very interesting point. Some people in the C-suite are fearful, and some people realize you have to embrace change. So can you all maybe talk a bit about how you address the talent gap within the enterprise? How can you make sure that if you're selling something, there's even going to be the requisite knowledge to actually use those technologies? Maybe you, did you want to start with that, Daniela, just because you start? Or Sherry, why don't you start?
Sure. So 100%, that's the case. What we see customers really having appetite for is, efficiency improvements, right, within their business using, Gen AI, particularly across all industries. And so the prior panel, for example, on customer support is a key example of where there is, again, allowances for, using Gen AI, even if accuracy isn't yet 100%, even if then you can just, escalate to a human, or even if latency may be, not as performant as you would like. In areas, and again, just sticking with finance, since we're in New York, where there's like potential for, alpha gen or, generating new opportunities, I'm also seeing quite a bit of appetite there. So in the area of, say, quantitative trading, we see the use of Gen AI being used in accelerating hypothesis generation. So for asking questions of if the price of bananas go up in Ecuador, how is that going to affect the geopolitical, climate in Central America or something like that? Typically, quants would have to go through several databases and do analyses. Now they can just do text to SQL type operations in Gen AI. Additionally, on the retail side of finance, what I'm seeing is new opportunities where the larger banks are providing to their retail customers Gen AI, beginning to questions like, how much did I spend on Uber on my credit card in the last 3 months, right? And being able to do those types of analyses, and then, opportunities for cross-sell and upsell during those interactions. So, I don't see as much, like I can, from what you're saying about executives being concerned, I see them being cautiously optimistic, but definitely wanting them to see profitability in all new applications.
Profitability meaning assuming that there's going to be some ROI in terms
Correct.
of what expenses incur.
Correct.
Got it. No, that's really interesting. I mean, some of the audience members are asking about how you deal with silos and also just issues of data quality, right? So if it's garbage in, it's garbage out. So would any of you like to talk about some of those issues of data silos and data quality?
Yeah, of course. There's always going to be these issues, right? So if you think about, like one of the things that has become painfully obvious is because of generative AI, everything is now a living interface. Your data is something that's interactive, right? But you need to have access to that data and have it properly integrated to be able to access it. And a lot of enterprises have a lot of different silos, like take healthcare, for example, right? Most of those companies have a lot of their data that is very valuable just sitting in filing cabinets, and they have people that are still sitting around just like manually looking through things, especially in government. That has been a thing for a very long time. That does have to change, and you have to treat this as a systems problem.
If I could just add a quick, so, what I'm seeing now is, customers giving us samples, maybe 100 or 200 prompt responses, and then being able to utilize different types of data synthesis generation. We're, creating millions and millions of different, training examples from that. So, like 2 points. One is there may be in the future less of a need, all right, for, customers providing lots of data, and two, I think there's a huge runway for synthetic data generation in Gen AI.
Yeah, I think about data quality, if you think about an AI system is, automating some task, just like an employee does a task, and now we have these digital employees, or we will have digital employees that do tasks or help with tasks. A human employee starts out not very good, and as they do their task, they get feedback. Somehow in the process of doing their task, they get better at it, right? That's like the nature of people. And this is why you hire people and you invest in them. You invest in their training, you invest in them doing their jobs, and senior people are paid more than junior people because they're presumably more valuable, right? These are very intuitive thoughts to all of us. There's no reason why an AI employee is any different, right? When you first deploy it, it's trained on, whatever data it was trained on. And as you say, a lot of data that you might use to train a AI system on how to do a task is of variable quality. We've definitely worked with lots of companies that, we say, okay, well, hand label 500 examples. They give you 500 examples. And then you actually go in and look at it and you realize maybe 20% of it's actually pretty good. That's very typical. So you have to accept that when you first deploy a system in practice, you have the theory, it's going to be beautiful. We trained it on this stuff. And then, rubber meets the road and you start using it. And it's good answer sometimes, bad answer sometimes. You have to build into your fundamental computing architecture the ability for systems to improve as you use them. You could call this a flywheel, right? The more I use this system, it gets feedback. The human copilot, if it's like a copilot, the human who's using it says, oh, that wasn't right. Or, you collect your logs and you filter them and you find good and bad examples. But you have to build these mechanisms in. And the more you use the system over, months and years, it gets better and better and better. And that's the nice thing about AIs is these improvements can be very measurable and monotonic, right? And repeatable. So I think this concept of data quality really, the ultimate solution is you have to build flywheels into all the way you deploy these systems.
Can I say just one thing? Because data quality means a lot of things in my world right now. It can be the adherence to the technical specs on the collection side, but it also has to do with the consistency of the annotation of the original data sets, because otherwise, the thing about data, the data is only good if it's structured, even though there's a lot of non-structured learning out there. It has to do with diversity of the data. It has to do with non-bias in the data to be high quality as well. And it now more and more goes down to does it meet all the checklists of legal traceability to the consent to the level of the contributor. So it's a lot. And we do not see, I love the idea of synthetic data rise. I do think I'm a great believer in that, but I do not see our customers after that at all. And there's a lot of studies lately showing that the models are much further degraded when you insert them synthetic data in the training data more and more.
So synthetic data definitely does have an impact, right? But it is, as Sherry mentioned, it's getting better and better. And there's a lot of future unlocks that are just now happening, right? For example, one thing that we haven't spoken about is evaluation metrics, right? But for me, when you're thinking about deploying something in production, it starts with evaluation metrics. What are you measuring? What is the time to business value? Where are you getting ROI from? And that dictates the kind of data that goes into the system. And then you can build flywheels and everything off of that.
So I'm really glad you brought this up because I know, Sherry, you mentioned that, you'd like to see business cases where there's ROI. So a few people here have been asking, how do you ultimately, think about structuring ROI for AI use cases? So first of all, some of you here on this panel, I imagine there are startups pitching you, right, to see how they can partner with an NVIDIA or Amazon, Lemurian, or Defined. What type of things should these startup entrepreneurs think about in terms of ROI metrics?
So it's just for us, when we speak to customers, it's an optimization of the golden triangle of accuracy, cost, and latency. And so everything we build, for the customer is, optimized, against those three things. So when you're when you're building a Gen AI application, you have to look at the cost of, compute. You have to look at, how accurate your results are and create correct benchmarks for that. As well as you have to look at the overall costs of the power, compute, and other services that are being used to host your, application. And it just gets very expensive, very quickly. So, my advice is, try to be as cost efficient as possible in your applications, because in the end, what I've been seeing with C-level suites is that models are, slowly becoming easier to choose from. It's not 2 years ago when it was just, one model provider, and they're looking for the cheapest possible model, that, has the level of accuracy that they're looking for, given a certain latency constraint.
Got it. Maybe we could talk a little bit about just the conversion of pilots to larger contracts, because a few people have mentioned this earlier, that there's a lot of people who are testing the waters, putting up things on the, trying to, figure out if they're going to pilot, which is like, there's a very, short decision process for that. But to move it into a larger scale contract is difficult. McKinsey did this study as part of this AI board that New York State commissioned, that talked about 5% of actual POCs are actually going into larger contracts. Is that consistent with what you all are seeing in your project? That seemed like an incredibly low number. And how can we possibly increase that actual conversion rate?
So for us, I would say a year and a half ago, like a year ago, it was much, much lower. But right now, we are seeing more and more pilots moving into production, just because of the competition, within the market. So again, C-level is viewing their competitors moving Gen AI agents into the market, and they're looking to be much more cost efficient in different ways. So we're seeing an acceleration, but the numbers are still low.
What would you say they are on average? What would you guess?
I would probably say now closer to half.
Half. Okay. Yeah. Anyone else have any other points that you have?
Yeah, absolutely. So one of the things that is obvious, of course, is people are generally thinking a lot about the model, and they're over-indexing on the model itself. But in reality, when you think about agents, there's a lot of things around it, which is much more important to think about, right? So if you're thinking about a RAG or an agent system, or if you're thinking about guardrailing, all of that really, really matters. And that's the thing that people don't think about as much when they're shipping to production. And that's where most of the failures happen. Again, set your evaluation metrics, think about guardrailing, think about how you're doing fine-tuning, think about what kind of agent architecture you're using, how you're doing RAG, and what that means, especially from a scalability point of view. Because one of the things that you as a business have to take into account is, again, your time to business value and how you're going to be scaling and what that cost is to you, and how your customers are going to be dealing with the latency and so on.
So two maybe rapid fire questions, because I know we just have a few minutes left. So you talked about the importance of, understanding the enterprise architecture. So back to this question of silos, which a bunch of our audience members are asking about. How do you break down the silos? I think one of the prior speakers was talking about how some of the technologies people are using in the enterprise are still in the 1990s or so, 2000s. And that's a big switch from going from mainframe and COBOL type of technologies and insurance to generative AI, right? So what are some things that people can do to ultimately break down those silos?
Well, I mean, so silos happen for many reasons. And it's hard to say this solution, this technology will cure all of your silos. But one of the causes of silos is you just have very incompatible systems and complicated APIs for sharing data across them. The promise, I think, of generative AI and these modern agents and large language models is, they're able to talk to many systems in a more seamless way that can call APIs. They can reason and in a limited sense, make plans about, I'm going to need this information and this information and that information. And so I think, there is a path here through this technology where you build agents that have access to different silos of data and allow them to synthesize answers. Data warehousing was like the big idea, like you dump all your data in data lakes and
ETL,
software that can pull it together. And, it's very hard because it's very manual. And with modern agent technology, in theory, and in practice, I think you can actually automate some of this stuff that in the past was very manual. And I do think that's going to be a key to enabling information to cross boundaries that were very difficult to cross in the past.
Thank you so much. Well, I have one last question, and I'll keep making it a little more lighter question. But so I want to think about I think for those people who are enterprise buyers or people like me who are venture capitalists, I think we're just feeling this like fatigue about AI, right? Like we see companies pitching us that are dog walking applications that are saying that AI is going to be this whole LLM strategy. I'm serious. I had a guy pitch me a fly fishing app marketplace just last week and spent half of the deck talking about his LLM strategy. And it's just really hard not to just tune out. So I'm just curious.
Love it.
You like it? So should I invest? Okay. Yeah. So
love that it's happening.
Okay, got it. So the thing is like, just where are we? I think a bunch of us here on this panel, I'm not trying to date us, but I think we're here during the 90s and the early 2000s era, right? And so are we in 1993? Are we in 1997? 2000? The idea is that part of why I'm asking this question is that a lot of people failed in the earlier ages of innovation where they were just too early. Right. And what I'm saying is that whether you're an investor or an enterprise, you might just say, will I take the bet on this vendor or this technology when in a year or two it's going to be obsolete? It's too early. So the question is really like, where are we in terms of AI adoption cycle? There's obviously a lot of hype and there's a lot of exciting things happening, but where do you think we are in terms of
It's a little unfair asking me about a year I wasn't even born in.
Thanks for rubbing that in. Thank you for rubbing that in.
But yeah, no, it's true of every single technology cycle ever. It's whenever something new is coming exciting and there's a lot of uncertainty, everyone's going to jump in and try and figure it out and hopefully find a use case that's of value, right? So when AI started picking up and became obvious that, it's going to require a lot of flops to do this stuff, everyone and their grandmother jumped in and started building chips, right? But, we already had really good chips. We didn't need a whole lot more. Like for some use cases, it makes sense, like for the edge. Right, but for the data center, there's different requirements.
Totally fair. Any other person want to comment on what year we're in?
I was just like in the 90s, we start seeing the first mobile phones, and technology was so expensive, and then everybody adopted it. In this world of Gen AI, I feel like we're going to see more people, and we see that too, more people taking the development on their hands, developing more, whether it's their LLMs or LVMs or whatever model. Technology will become cheaper, more accessible, and we don't have to have a PhD all the time in this area to build models like that. It's going to get there.
Yeah, I think... Oh.
No, please go ahead, Sean.
I think we're at the beginning because if you look at, power, compute, and architectures, we have a lot more that we can add juice to in all of those three.
Thank you, Sean.
I guess an analogy I'd offer is like computer graphics. Jurassic Park, I think, was 1993. And we're in the era now of digital effects in movies. 20, 30 years later, it's not over. There's more to be done. The first interactive 3D video games, to date myself, when I was like in high school, video games are still interactive in 3D. We still use those words to describe them, but we're just in a completely different planet from where we were 30 years ago. And over the next decade and the next few decades, video games are going to get even more immersive and more incredible. And so I think AI is similar. This is very deep technology. It's amazing. The first time, you played with ChatGPT, your mind was blown. But we're still in the first innings, barely.
Yeah, we're very much, we're still in the steam engine days of computing. So things will get cheaper. Think of it as a platform, and everything on top is really where you want to be playing, because that's where the real stuff is.
Well, with that, I know there's so many other questions. I hope you can have a chance to speak with our speakers after this panel, but please give a round of applause to our wonderful speakers. Thank you.